Now in this particular problem, it's set up to where this kind of a scale would work fine. You could have set it up different ways. This is just how I happen to choose to draw it out. And I want to go ahead and start just marking some of the stuff along the way here. Now the first thing I always like to mark on these is any maxima or minima. I want to put the extrema on my graph. So I have a local maxima at -3, 10. So with my scale and the way I happen to choose to set it up, it's going to be there. Now I know that is a maximum, and so I'm going to remind myself that it's a maximum by kind of putting a little curve there so I can remember that that's where it's going to top out. Okay. And then we have another maximum over here at 5, 0. And again, I put the dot there, and again, I'm going to put a little curve through so that I remember that's where it's maxing out. All right, now I'm going to go ahead and go to my minima. So we got one at -5, -20. And that's a minimum, so I know it's going to be bottoming out there. So I'm going to put a little curve showing that that's the lowest it'll go around that point. And again, at 1, -10 for my other one. And again, I'm going to include a little bit of curve to show that that's where it's going to bottom out. Now, just seeing that much, we actually can know quite a bit about how to draw this graph, right? But we got some other details in here. Specifically, the points of inflection are going to be very useful here because we know that it must go through those exact points. So I want to draw those points in. So we're going to have -4, -5. I'm not drawing any curve or anything through that one because that's a point of inflection. It's where it's changing from concave up to concave down or vice versa. So I'm not as worried about showing that it like tops out or bottoms out there. I just am going to have to pass through it. And then at -1, 0. Another point of inflection, and then at 3, -5. Based on those points alone, I could probably make this graph, couldn't I? Yeah. So I'm going to go ahead and try that. I'm going to go ahead and make the graph just using those points here. So connecting up my maximum here with my minimum. And then heading over here, I'm going to do the same thing going to the right of that. And then continuing on from there. Oh no. Now, I didn't quite fill in the ends yet, but I know that like on the left side here, this end point, that was a local minimum. So I know it has to be going up from there. There's no more point of inflection on this side though, so I know it's got to be concave up still. And on the right side, same kind of a thing. There it's going to be going down because we know that we were at a maximum, so of course it has to be lower than our maximum. And the concavity doesn't change. We know the concavity doesn't change because there's not another point of inflection there. And so that can give a rough idea. Now, before we go further, though, let's check and see, because I didn't even use some of these other pieces of information in here. Let's make sure that it still fits with that. So, is it increasing from -5 to -3? Yes. So what we're looking for then is we're looking to see between -5 and -3, is the graph going up, in other words, positive slopes? Yes. And so we can see that. Is it also increasing from 1 to 5? From 1 up to 5.
Yep.
Positive slope throughout that. So yes. And we could check the same thing with the decreasing. And the decreasing, of course, there's 3 different intervals. And yes, it is decreasing on each of those 3. Last thing though, let's take a look at the concavity and make sure those are making sense as well. So is it in fact concave up from -infinity to -4? So that's from -infinity over to here. Is that concave up?
Yes.
In other words, a way to remember concave up, is the cave opening upward?
Yes.
Yes. Okay. And then at -1 up to 3, so -1 up to a +3, is that concave up? Yep. These are the sorts of things we can look for to then verify it. And so notice our process of sketching the graphs. We started by plotting any actual points that we had. So maxima, minima, and inflection. And then once we plotted those points, we can sketch the graph, but please do not forget that last step that we went through where we actually checked it against those other pieces. Because that way we can catch any mistakes we might have made or observe if there's anything kind of funky about the graph, because there are some little variations that can happen that maybe aren't quite what we're used to seeing. So, first up, first thing we encounter here is increasing. When we do increasing, is this an interval or is it a point? It's an interval, exactly. So if we're looking for increasing, that just means where is my slope positive. So we're going from here to here for increasing. So that's going to be from -5 up to a +1. So we're just going to say -5 up to 1. Remember, parentheses, not brackets here, because we are not including the points, because at these endpoints, it's not increasing or decreasing. My slope is 0 there. All right, decreasing. Notice we got two different sections where it's decreasing. It's everywhere where it's not increasing in this particular case. So that's going to be from -infinity up to the -5. And yes, we include the union between them. And then we go from 1 up to the positive infinity. And so notice that to the left of this point, it's decreasing. To the right of this point, decreasing. We're just looking to see if the slope is positive or negative for that. Now, how does this help us, especially as we look towards the test? If we understand or remember what we're looking for at the graph, it's also going to help us remember how to calculate it. Because oftentimes, this is what we're seeing now, right? Wait, do I use first derivative or second derivative for this? That question comes up a lot. Well, when we're talking increasing and decreasing, we're looking to see if the slope is positive or negative. Slope is determined by first derivative. And so if you know that, it's going to help you to keep track of it. Right.
Wait, no calculators?
Now for the maximum and minima, are those going to be intervals or points? Points. Because we're actually looking to see the exact location of where that maximum or the minimum occurs. Now you notice we got one of each in this particular case. So we're just going to give those points. So like the local maximum is going to be here at 1,8. Now, you notice I'm asking about, is it an interval or is it a point? Partly because they look a lot alike, don't they? And we want to make sure we're keeping straight exactly what it is that we're actually dealing with in each of these. All right, now in this one, do you see any points of inflection?
Yes, 1.
Yes.
-2,5.
We got that thing actually labeled there. So yes, we're going to go with -2,5. Is there any other point of inflection here?
Probably is, but I don't know.
Well, first of all, we don't see any other points labeled, so that would tend to make us think no. But remember what the point of inflection means. It's where we change from concave up to concave down, or vice versa. Well, taking a look, let's actually go down here and do the concave up and concave down, and then we can decide if it changes. So, where is this graph concave up? Yep, looks like all the way from -infinity, yes, up to here. So notice, the cave is opening upward through there, right?
Elaine, are you awake?
So, -infinity up to 2. Okay, now. Oh, yep, negative, thank you. Now, on that interval, yes, it is concave up. Is it concave up anywhere else? No. So that means that it does not change concavity again. Therefore, this is in fact our only point of inflection. So we're just able to confirm that. And then for concave down, of course, that's going to be to the right of the negative. So these are all of our answers there. Go ahead and check those, make sure you got them all right. So as you take a look at this, I'm again going to start with just the regular points.
What are you doing with
So I'm going to start by plotting the local maxima and minima. So we got -4,2 for a maximum. And again, that's a maximum, so I'm going to draw a little bit of that curve there so I can remember that. And then we got a minimum at 6, -5. But notice we got a lot more points of inflection. So I got a point of inflection at -6, -3. -1, 0. To -2, which is where things start getting interesting, right? And then from 4 at 4, -3. So remember how I drew in the little bit of curve? That helps us to keep track of which ones were maxima and minima, and which ones were the points of inflection. But we got this weird little trio of points of inflection here without a maximum or minimum in there. Well, that suggests to us that we actually have something that you've seen before on like the x cubed graphs, where we're probably going to be doing like one of these kinds of things right around there. So let's actually check it out and see here. And I can know that by looking at the concavity intervals as well. So those are now going to give me a little bit more hint. So notice that it's concave up. So we're going to go from negative infinity to negative 6. So through here it is concave up. Now that would fit with my maximum. So I can go ahead and just draw that straight down like that. And I'm going to be good there.
Oh, no.
Now from negative 6 to negative 1, it's going to be concave down. So that means the cave is opening down here.
But negative 6 is all.
Yeah, sorry, I looked at the negative 6. I plotted that wrong spot. Concave up, rather, should be from the negative 6 over to the left. So we're going to be like this. Okay, now we're talking. Now we're concave down from negative 6 to negative 1, right? So that's going to be from here to here. So that's going to be concave down. All right. That seems fairly straightforward, at least there. All right, so we can see that much.
Wait, isn't that what we just had?
But now we need to start taking a look at what's going on with these, right? So, after negative 1, it's going to be concave up. Because notice, from negative 1 to 2, it's concave up.
Where does it?
So we're going to be doing one of those, a concave up between them.
Big shack.
Then after 2, from 2 to 4, notice it's concave down. And so notice what happened here. This is where it was kind of like x cubed, where it kind of levels off, but then it continues on. So yes, it actually did do that here. And then concave up from 4 all the way over from there. So it's going to be concave up from here. It's just going to be doing one of these things. If I can draw a nice curve at least. So this graph should end up being simpler than the last one, because the last one, yes, was showing you kind of that weirdness. What happens when it kind of levels out in the middle, but then continues in the same direction, that sort of thing. So this one hopefully will be a little bit more straightforward. This is the sort where by now it should be seeming pretty doable, whereas the last one, yeah, it was trickier. So that was meant to be tricky, but this isn't. All right, first thing I do is I plot the actual point. So negative 7, 7, that's going to be a maximum. And at 1, negative 1, we also have a maximum. We got a minimum at negative 1, negative 3. So we're going to be right over here. All right, and then remember that as you're sketching those in, I'm kind of putting in that little bit of curve. That way it just helps me to remember that it's a maximum or a minimum through there. Last thing I'm going to put on here is the points of inflection, negative 4, 2. And 0, negative 2. And we can now sketch our graph that goes through these. Now, some of it's pretty easy, right? Now, on the left, am I just going to be able to go down like that?
No.
If we do that, does it match up with where it's going to be concave down?
Because there's no point of inflection.
Yeah. Yep.
And it's not
So it does. So I'm going to draw it a little bit more cleanly, but yes, we can go ahead and do that. And notice it's also concave down from 0 out to infinity. So as we go to the right, it's also going to be concave down over this entire interval over here as well. And so then this is a fair drawing. Now let's go ahead and check that against our increasing and decreasing. It doesn't have the error in it like the last one, I hope. So is it increasing from negative infinity to negative 7? Yes. Then decreasing, negative 7 to negative 1 here. Yep, that is entirely decreasing there. And then from negative 1 to 1 it is increasing, good. And then from 1 out to infinity, yes, it is decreasing. So it all matches up, and our concavities match up. So this is the correct answer.